MEM School of Engineering, Department of EEE, online classes, subject Digital Logic Circuits, unit number 3. Okay, so last class we discussed different kind of flip-flops. Now we are going to discuss about triggering a flip-flop, how we are going to trigger. So there are two type of trigger, that is edge triggering and level triggering. So edge triggering enabled by the positive or negative edge of the digital waveform. So level triggering enabled by a logic high or low level. So flip-flops are synchronous bistable devices. The term synchronous means that changes in the output occur at a specified point on a triggering input called the clock. So that is changes in the output occurred in synchronization with the clock. So based on the specific internal or point in the clock during which triggering the flip-flop to change the output state. The triggering method can be classified into two different types, level triggering and edge triggering. The flip-flop circuits are constructed in such a way to make them operate properly. When they are part of a sequential circuit, they employ a common clock. For proper operation, the flip-flop is to trigger it only during a signal transition. The pulse goes through two transitions 0 to 1, that is positive level triggering, and the return from 1 to 0, that is negative level triggering. A flip-flop that triggers only during a signal transition and is disabled during the rest of the clock pulse duration. So edge triggering flip-flop, edge, the high to low or low to high transition of the pulse wave. So edge detector, the circuit and edge triggered flip-flop converts active edge of the clock into the active level pulse at the internal latch set and the reset pins. So edge RC circuits depend upon a charging time. The clock is converted to spike using the RC combination circuit. Usually capacitor in series with the resistor used for this purpose. The positive and negative voltage across the resistor appears only during the positive transition of the negative flag. The positive voltage spike occurring in case of positive edge trigger. So flip-flop if proper signals are available in the condition. This is the waveform at output of edge triggered circuit. So this is the circuit for edge triggered circuit. This is the truth table for positive edge triggered D flip-flop, that is, so when condition clock 0, so it is a present state. So what is a value will be that, that is q of n. When condition 0 to 1, that is positive edge means 0 to 1. So if 0, t value is 0 means output next state will be reset. Okay, that is data. If 1 means it will be 1. If down clock pulse means it will be a present state. That's all. Okay, that is the value of d given to the output. That is the concept. So this the next one is edge triggered JK flip flop. Same. First clock pulse will be a no change. Second will be a reset. Next will be a set. So final will be a toggle. So next already discussed the excitation table. A table showing the required input condition for every possible transition of a flip flop output. The excitation table consists of two columns, Q of n and Q of n plus 1, and a column for each input to show the required transition can be achieved. The excitation table of RS, JK, D and T flip-flop are given below. So this is excitation table. So last we did that. That is present state and next state. If 0 present state, next state 0 means what are the condition of input? Okay, that is maybe it is a reset enabled or no change condition. So we are putting a x0. Okay, then JK flip-flop. This is the JK flip-flop excitation table. When 0 0 means it will be 0x. 0 1 means it will be 1x, 1 0 means it will be x1, 1 1 means it is x0. So same as D flip-flop excitation table and T flip-flop excitation table. Already we know that characteristics table of process. Why we study the excitation table and characteristics table? Because for realization of flip-flops, that is conversion of flip-flop from one to another, we need to know. Okay, that is realization of D flip-flop using SR flip-flop. So consider the realization of D flip-flop using SR flip-flop. We need to do the particular step. First step one, you have to draw the block diagram. Then truth table. Step two will be truth table. That is truth table for record flip flop. Truth table for record flip flop. So record flip flop will be D. So we are using the flip flop input and the process state next state. Okay. Then excitation table SR for input flip flop. SR excitation table for input. So you have to conversion table like this combined here. That is input D, present state, next state, then RS. So using this table, you have to find out this value. For this value 0 0 means 0x. Okay, here they are changing the R and S, so it will be confusions. So you have to consider with the like this. Okay, that's the concept. So next you have to draw the K map. So after K map draw, you can draw the block diagram of the conversion of SR flip flop into D flip flop. Okay, SR flip flop into T, same concept. We are getting the excitation table of rec from table and compare with the T, then you will get the came up value and the logic diagram. So these are the realization of flip flops. So first you need to know, so what are the conditions? Okay, so that is, so these are the steps for converting the one flip flop to another flip flop. That is, first we need to know the input and output, then you have to define the truth table of output flip flop, then you have to write the excitation table for input flip flop, then you have to compare these two, then you will get the some value. Using this value you will get the you have to draw the k map and get the characteristics equation or final equation. Using this equation you have to draw the logic diagram or block diagram. This is the concept we have used in the realization of flip flops. So next class we will discuss with the registers, that is memory element, how to design a memory of memory with the help of flip flops, because flip flop is a 1 bit storage device. For 4 bit use you have to use 4 flip flops. Okay, like that we are going to see in the next class. Thank you.